Part C is about the complement of a set. Before starting this complement, let's introduce new set, and let's call it universal set. Universal set is a set of all elements we are considering. It's up to you what we call the universal set. For example, let me call universal set. We show with the U. Let it be the numbers from 1 to 10. 4, 5, 6, 7, 8, 9, and 10. This one is my universal set. And I introduce one set here. Let it be the set of these numbers. 2, 3, 4, and 5. And this one is subset of my universal set. A is subset of my universal set. And what's the complement of a set means? Complement of a set A. What does it mean? All the elements which are not in A. Or we can call, I have a universal set, these numbers, I have a subset. If I call complements of A, is the leftovers, outside of A, the elements which are outside of A, which will be the notation of complement. It's like a prime, A prime. And inside that number, what we write, all the elements which are not in my A, so it's 1, 6, 7, 8, 9, and 10. So this one is my complement of A. Or for example, this one was the first example. Second example, let me introduce, let's call it a set of positive integers. Okay, and let me 2, 3, 4, 5, 6, 7, and it goes till the infinity. All the integers, positive integers. And let me introduce one subset of these positive and let it be even numbers. And we know what are the even numbers are. 2, 4, 6, 8, 10 goes like this. And my question is, what will be the complement of B? What will be inside this set except for even numbers? It will be, of course, odd numbers. We have a special name for the odd numbers. Odd numbers. So complement of the even numbers are odd numbers, or reversely, if I introduce an odd number set, the complement of the odd numbers will be even numbers. And some conclusions, and one example let's solve. Intersection of your set and its complement is always empty set because they do not have nothing in common. Their union will give you always the universal set, which makes sense. And the addition of elements in your set and in your complement should always give you the number of elements in your universal set. For example, let's see one example from your book. Question number 3. What does it say? You have the universal set with these numbers from 2 to 8. You have a subset A, 3, 5, and 7, and the set of B, 2, 4, 7, 8. Find number of universal set. So let's try to answer the first question, number of universal. We just need to count how many elements there are. 2, 3, 4, 5, 6, 7 elements. So number of universal set is 7. And how about the number of in A? As you can see, it's 3. And number of elements in a complement, if it's 3 and the universal is 7, it must be 4. Remember, complement and the A, when we add them up, it should always give the universal. This from third part, we can conclude. And this one was third one. And number 4, number of elements of B, as you can see, it's a 4, and the complement will be 3, of course. Complement will be 3. Now, part B, what does it say? Copy and complete. For any set S within a universal set, number of S plus number is always equal to the number of elements in universal set. If you have any set, and if you add its complement, number of complements, it should always give you number in the universal set. Or we can write it like this here. Again, conclusion from here for any set.